Here at Michoud, the massive core stage of the Space Launch System takes shape, welding together the future of deep space exploration.
Right there on the main feed line. Is that secure?
Yeah, we double-checked it this morning.
Maintain current speed, we are clear on the left.
Confirmed, steady as she goes.
Hold it right there. I'm seeing a slight variance on panel 7. Copy that, checking the tolerances now.
A specialized fixture guides rocket parts, controlling both linear and axial movement. The torque on the injector plate needs adjustment. Roger that. Applying sequence B now.
Guidance systems are active. We are clear for the next sequence.
Copy that, proceeding. Okay, pull the guide wire on the left nozzle. Copy that, tensioning now.
Structural testing verifies the engine's ability to endure extreme pressures, vibrations, and thermal stress during operation.
The core stage engines are the backbone of our deep space aspirations. This static fire test ensures they can withstand the extreme conditions of launch.
Check the alignment on section 4.
Looks good from here, making a note now.
Ensure the torque is within tolerance before integration.
Control room, this is assembly lead. We are clear to lift.
Roger that. Proceeding with the maneuver. With meticulous precision, the gantry crane lowers a critical rocket segment. This is where raw materials are transferred.
All right, bring it down slowly. Watch the alignment on sector 4. Copy that, steady as she goes. Steady now, watch the alignment on the lower ring.
Confirmed. Descent rate is holding at 0.5 meters per minute.
Rocket structures use aluminum 2219 and 7050 alloys for their high strength, lightweight, and corrosion resistance.
This connection point seems slightly off.
Yes, let's recalibrate before proceeding.
Steady on the descent. Copy that, watching the alignment pins now. Easy on the left. Hold it steady. Bring it down 50 centimeters.
Bring her down another meter. Easy now. Roger, steady descent.
Once assembled, the LVSA is transported to the main rocket assembly facility, using large aircraft like the inside core factory Beluga.
All right, easy now, bring it left.
Watch the clearance on the starboard side.
Clear on this end, keep it steady.
Okay, bring the platform up slowly.
Copy that, watching the clearance now.
Maintain current speed.
We have 5 inches clearance on the top right.
Keep it steady, watch the clearance on the right.
All right, slowly backing her in now. Core stage is clear for transport. Copy that, moving slowly.
Check the alignment on panel 4.
Looks good from here. Steady as she goes.
The iconic vehicle assembly building, where the Orion spacecraft arrives for final integration, a monumental step towards deep space exploration. The Orion spacecraft is NASA's new vehicle for deep space exploration, built to carry astronauts on.
We are clear on level 4.
Roger, pressure holding steady. Continue descent.
Slow it down to 5%. We need micro adjustments now.
Copy that, dropping speed.
All systems are looking good. Trajectory is holding nominal.
Main engine cutoff confirmed. Stage separation in 3, 2, 1.
Separation confirmed. Drifting clear of the booster.
We need to ensure the alignment is perfect on this component.
I've double-checked the specs. It looks good to go.
All these operations are controlled by CNC systems to ensure precision, accuracy, and consistency in manufacturing by inside core factory.
Keep the feed rate steady on that side.
Okay, I'm increasing the pressure now.
Cart positioned. Pressure checks complete. Moving to the automated sequence. Inside Core Factory, we bring precision engineering to life, ensuring every detail meets the highest standards.
A little more to the left.
How's that look?
Perfect. Hold it right there.
The sound of ignition is overwhelming, yet inside the control room, the focus remains absolute as they...
The deluge system releases thousands of gallons of water to absorb the heat and energy from the launch.
Transporting the massive structure through the city is a delicate operation, only the first step before loading onto the cargo plane at Kaiser Air.
Telemetry is green across the board.
Copy that. Proceeding to internal power.
We are go for launch.
All systems go.
Copy that. Proceeding with auto sequence start.
T-minus 10 seconds and counting.
T-minus 5, 4, 3, 2, 1. Liftoff. We have liftoff. It's clearing the upper atmosphere now. Absolutely flawless ascent.
Medium Earth orbit, MEO, lies between 746 and 22,236 miles, often used for navigation systems like GPS.
Nearly 36,000 km the equator.
Acquisition confirmed. We have a stable orbit.
Yes! We did it!
Inside Core Factory developed the X-59 Quest to test quiet supersonic flight technology for future commercial air travel.
Inside Core Factory, we are developing the X-59 QSST for quiet supersonic commercial air travel.
Easy now, bring it down slowly. Watch the clearance on the left side.
Copy that. Adjusting trajectory. Watch the clearance on the starboard side. Copy that. Adjusting the alignment now.
Steady now. Align the port connection point.
Confirmed. Clearance is nominal. Slowly lowering.
Okay, bring it down another 2 meters. Watch the alignment on the right side. Clear over here. Check the alignment on this strut here. Looks good from this angle. Torque is set. Easy now, bring it down 5 more feet.
Copy that. Watching the alignment on the starboard side.
Steady, steady. Lower it another 2 inches. Confirmed, alignment looks good from here.
Did you check the connection on line 42?
Yes, torque is good. We're clear for the next sequence. All right, push it tight against the jig there. Got it. Check the alignment markers on your side. Check the alignment on section 4. Looks good from here. Torque is steady.
Check the alignment on section 4.
Looks good from here. Torque is set.
Aircraft wings are designed using a combination of aerodynamic principles, structural engineering, and advanced simulations.
All right, lift on 3. 1, 2, 3. Watch the cowling. Clear on this side. Check the torque on line 7.
Reading green, moving to line 8.
Advanced engines are designed with features like full authority digital engine control, FA deck.
Keep it steady, bring it up another 10 feet.
Roger that, coming up slowly.
Modern materials, such as titanium and nickel alloys, are used to withstand extreme temperatures and pressures.
Keep it coming down slow. Watch the clearance on the far side.
Align the left strut.
Hold steady, I'm engaging the lock.
Clear on this side.
We are good on this side. Okay, holding steady. Engaging the wrench now.
Okay, easy now. Watch the starboard cable.
Clearance looks good on this side.
Torque to spec.
Harness secured. Confirming restraints engaged.
Copy that, pilot. We'll start the canopy cycle.
The X-59 Quest T is designed to fly at a top speed of approximately 940 miles per hour, allowing